this video, we will start with revision exercise 2, sequences, series, and the binomial theorem. You will find this on page 94 in the Namibian AS-Level Mathematics textbook, Y equals mx+c to success. In this video, we are going to focus on 1, 2, and 3. You can stop the video and try to do it on your own, and as soon as you are finished, you can continue the video. Let's start with number 1. The first term of a geometric progression is 81. Okay. First, let's write. It's a GP. Very important. Okay. The first term is 81. The fourth term is 24. 24. The common ratio, find the common ratio of the progression. Okay. Now, if we're going to start, and you can also see this on the formula sheet, I'm just going to show you quickly, but you will also know this. Okay, I just want to show you. I'm just going to take it away afterwards. There, on the formula, the GPs, and there is Tn. That is the formula for Tn. There you will find your formulas. But I think you know it also from ordinary level. Okay, so I know that Tn for a GP is A or n minus 1. So if for the fourth term, 24, the value of A is 81, and then it's R, and it's 4 minus 1. Then it's 24 over the 81, and that's R to the power 3. First, simplify that. So if you simplify that, you can press 24 ABC 81. It will simplify on your calculator. Or divide by the same number top and bottom. But you will get 8 over 27. And to get that 3 away, you take the cube root. And that will give you 2 over 3. So you can say, therefore, R is equal to 2 over 3. That was the first question. Find the common ratio. Now, the sum to infinity. Okay, so that was A. Now let's do B. What is the formula again? S to infinity, and that's A over 1 minus R. And that is just going to be the value of A, remember, 81, and it's going to be 1 minus 2 over 3, the value of R. And that is going to give you an answer of 243. Okay, and then the next one, number C. The second and third terms of this geometric progression are the first and the fourth terms, respectively, of an arithmetic progression. Okay, so I think let's start with the GP. The GP was in yellow. Now, I know the first term was 81. Now, if I multiply with the 2 over 3, what do I get? So the second term will be 54. If I multiply again with 2 over 3, it will be 36. And again, 24. So that will be term 1, term 2, term 3, term 4. Now, let's see, the second and the third terms. The second and the third. Okay, we go on. And now they say, okay, it's now AP, but now I must just check the position. It's the first and the fourth. So the first, this is now my AP. So the second will be the first, and the third one will be the fourth. But it's still, this is still term 1, and that's term 4. But now I have enough information to work out the value of T. So APs, do you remember the formula? T in A plus bracket N minus 1 D. Now in the place of T, it's 36. I have A, 54. I have N minus, so it's going to be 4 minus 1. And then the value of T, which I'm going to find out. Okay. And then I'm just going to subtract that. So it's going to be the 36 minus the 54, and that's 3D. And if I divide and I subtract, I get that the value of D will be equal to -6. But what was the question? Let's go back to the question. The question is find the sum of the first 10 terms. Okay, so that was just to help me to find the sum of the first 10 terms. So I know the formula for Sn is n over 2a plus bracket n minus 1d. Okay, so if I find 10, so it's S10, it's 10 over 2a, remember your a is 54, and this is 10 minus 1, value of d is -6. I prefer to write it in front, it's not the influence. Okay, and then it's 108, and remember that's also in brackets, so if I simplify that, I get -54. And if I simplify all of that, I'm getting an answer of 270. And that, let's just go back, that is number 1. Okay, just want to make space again. Let's do number 2. I just want to get the line away. Okay, here it is. Let's start with number 2. Number 2. In the expansion there, okay, where a is a constant, the coefficient of x is -30. Find the coefficient of x to the power of 3. Now, in this case, I can say, oh, it's the binomial theorem. Now, the formula that will help you the most in the binomial theorem, and you can see it on the formula sheet, but I think I want you to show you it on this. Can I just go to the summary here? Just take a little bit long. The chapter is big, so it takes a little bit long. Okay, there, that one. That is the one. So it's going to be r plus 1, but I'm going to start with 0, always. Okay, so it's n over 0. I'll show you now. It depends on the terms. So if it's 6 terms, it's 6 over 0. And then it's the first term, and it's n minus r. So it will be the first term, say, 6 minus 0. And then the second term, r. So this formula will really always help you if you're going to do the binomial theorem. So let's just go back and let's just use it. Okay. So I'm going to first write that expansion. First, just like this. Okay. Now, remember, I want to have x and x free. So if I do this, I'm going to start by saying, okay, now that's what I said, 6 and 0. This is actually your first term. Take the first one, and remember the formula, what I said. It's going to be 6 minus 0, so it's 6. And then your second term is just going to be the value of r. And this is just going to be 0. So there's the first one. Okay, let's just go on. Then it's 6 and 1, and then it's 1 and 5, because I subtract. And then the second one, and it's 1, plus. Then it's 6 and 2, and then it's the first one, and this is going to be 4, and then it's the second one, and that is going to be 2. But remember, I want to go up to x3, and this is now first x2. I'm going to need, so let's just continue. 6 and 3, and then it's going to be 1 to the power 3, 6 minus 3, and then ax to the power of that r. It actually continues, but I don't need the rest. This is enough to help me in this calculation. So if I just want to simplify it a bit further, okay, and now can you remember on your calculator, you will find, if you want to press that on your calculator, I'm just looking for my calculator, and I'm actually looking for my other one. Okay, I found it. You see a key on your calculator, and it's looking like that. It's there somewhere on top. So it's N, C, R. That's the key on the calculator. So if you want to press this on the calculator, you're just going to press 6, then that NCR, and then 0. And your calculator is just going to tell you it's 1. This is 1. This is 1. So your first term is just 1. Okay. Then press again. Press 6, and then press that NCR, and then 1. And then what are you going to get? 6. Okay. And then it's 1. And then it's AX. Okay, I could have simplified further, but it's fine. Then you continue with this. So every time you press 6, NCR 2. And what are you going to get then? You are going to get 15. Let's just like that, 15. I'm now there. And then it's 1, and it's AX squared. Okay. Then it still needs just a little bit of space. Then you're going to press 6 NCR 3. And what are you going to get? 20. And then it's again that 1. And it's AX to the power of 3. Okay. Okay. So this is going to be 1. This is going to be 6AX. This is going to be 15A squared, X squared. And this is going to be 20, A3, X3. And it goes on. Do you have that? Okay. Now I'm going to start with the question. Read the question again. Okay, I'm just taking it a little bit back. They say the coefficient of x, okay, there is the coefficient of x. There's x. So they say the coefficient of x is equal to negative 30. So I can go and say 6a is equal to negative 30. So I want to find the value of a. So I divide 6, and therefore I get that the value of a is negative 5. Okay, now I must find the coefficient of x3. There is x3. Do you see that? Well, let's make it another color, green. So I can then go and say 20 a to the power of 3. Okay, I'm going to first get the whole term for you, just that's your term. And then I just substitute that negative 5 to the power 3 x3. And that, if it's negative 5 to the power of 3 times the 20, so it's negative 2500 x3. Don't stop there. Read the question. Find the coefficient of x3. So therefore, the coefficient of x3 will, let's just move up, be negative 2500, the value in front. And that's how you do number 2. Right. Let's make space. And do number 3, the last one in this video, in part 1. I will do the next one in part 2. And there it is. Okay. Number 3. Now, if I look at number 3, let's just start there, 3, and just read it. Find the term independent of x, okay, in the expansion of this. Now, you must know the term that's independent of x is x to the power of 0. That means it's the constant term. Okay, so let me just write it for you down. If the term is independent of x, then this term is the constant term. Okay, so therefore the power of x is 0. Power of x is 0. Okay, so let's just start by doing that. Now first, and this is the formula that I showed you now. The previous, I'm just going to say it like this. The r plus 1 term. Okay, I'm going to first work this out. Of this expression 2x plus 1, that would stands there, over 1 x squared to the power of 6. Okay, so I know this is 6, but I don't know the term. So I just write a general formula. So I make it 6 over r. Are you with me? Okay. Then I take the first one. And can you remember, it's this 2 subtract. So it's 6 minus r. Then I take the second term. No, just take it up. It's going to be better if it's x to the power negative 2. And then it's just going to be r. And now I first simplify this. Okay, leave this 6 over r. Okay, I'm breaking up this. So I'm making 2, 6 minus r. I make x 6 minus r. I make x is negative 2r. Okay. Okay. So you're going to get 6 over r. I'm just going to simplify this. So it's 2, 6 minus r. This is x. Now it's 6 minus r minus 2r. So it's 6 minus 3r. Okay, that's my expression. Now I'm going to go on. If we require, it's like we require, like this white statement I said there, 6 minus 3r. We want this one, this power, we want it to be 0. So that I work out the value and I get the value of r is going to be 2. Okay. So basically, I'm now going to say the term, so therefore, the term independent of x. Okay? So it's when r is 2. So it's substituting there. Okay, let's rather put the x on top there. Oh, sorry. This one. This is when r is 2. Then it will be that we get. So it's going to be 6 over 2. I substitute. In the place of r, I just substitute 2. So it's 2. So it's 6 minus, remember r is 2 also. And then x, 6 minus 3, r is 2. Now work it out. Again, take your calculator and press on your calculator that, I'm just looking for my other calculator. Okay, here it is again. So press on your calculator 6, that key NCR, okay, small r. So NCR and press 2 and press equal. Then I get 15. Then this is 2 to the power of 4 and this is x to the power of 0. And then I say 15 multiply 2 to the power 4 equals, and I'm getting 240. But don't stop there, read the question again. Find the term independent of x. So I can say, therefore, the term independent of x, or the constant term, is 240. And that's how you do it.